Yo, 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 what's up, Mr. White?
What's up, what's up, what's up? This is section 2.1, Relations and Functions. A relation is a set of pairs of input and output. So what we can think of is you have this blender, and you take a tomato, and you throw it in the blender, you turn it on, and what is coming out is tomato juice. You throw in carrots whole, you push, and out comes carrot juice. So think of it as like a blender. Throw in something, input, out comes your output. You can represent each relation in 4 different ways. Okay, the very beginning one that we'll start with, we'll look at ordered pairs. We have our input, comma, our output. We can look at it as x and y. So for instance, we have -3, 4, 3, -1, 4, -1, and 4, 3, and we can plot those points. We also have mapping diagrams. We have our input on the left, we have our output on the right, and then we can have arrows that point to or point from the input to the output. So 1 corresponds to 3, 2 corresponds to 5, 3, -1, 4, 0, and 5, 6. One thing we have to remember is arrows show how to pair each input with an output. Third one, we have a table of values. So generally we've seen this before where we have our x column, our y column. X is our input, y is our output. And then we also have our graphs where we can look at relations. The domain of a relation. Okay, the domain, we call that the inputs, or we also call that the x-coordinates. So we can get our domain of all of the x's that are associated with our function. The range is the set of outputs, also called the y-coordinates. So we have input, we have output, we have domain, we have range. We have x, we have y. A function is a relation in which each element of the domain corresponds with exactly one element of the range. So the first one, we want to determine if each relation is a function, and then we want to list the domain and the range of each relation. So first we can say, okay, well, we have to remember that each one of these x's can only correspond to one y. So we have 1, 2, works 3, 4 branches, and 5. So we have 1x corresponding to the 1y. So this is a function. Okay. The domain. Well, the domain is all our x's, so we can go 1, 2, 3, 4, 5, close brackets. And it's a little hard to see here, but the range is all of the y's over here, which we have -1, 5, 3, 0, and 6. So that's using mapping. We can also use the coordinates, or the points, and we have to look specifically at the x values first. So we have 1, 3, 5, and then as soon as we get to another one where it has the 1, we have to make sure that both y values are the same. And what we'll notice is for this input 1 we get a 4, for this input 1 we get a -8. So this is not a function. For our domain, we're just going to list 1, 3, 5. We do not have to list number 1 again, but we'll list 6. So we have 1, 3, 5, and 6. And then for the y's, or the range, we have 4, 2. We're not going to put the 2 again. -8 and 7. So we have function, x's corresponding to 1y, not a function because the 1's occur twice with 2 different y's. We can also use, if we have graphs, we can easily tell if it is a function by using what's called the vertical line test. So this helps us determine whether a relation is a function. The vertical line test states that if the vertical line passes through more than one point on the graph, then the relation is not a function. So simply what we can do, we can take our trusty handy dandy line and there's a line. If I were to take this and draw many of these, or just slide this all the way through, beep, 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 you'll notice that it only crosses our graph one time, keeps crossing one time, one time, one time, one time, and then to here where we get to the end. So we notice that it only really crossed the graph one time, so we can say that this is a function. If we keep dragging it to the next one, okay, we're going to start over here. We're going. As soon as we see kind of where, what you'll notice is we get across here, and across here. So at this x is about negative 2.5, you'll see that you really have 1, 2, 3 different y's. So this is not a function. Okay. And if we go on to the last one, take our line, we're sliding it, you'll notice that this crosses once, continues all the way, so it only crossed the graph one time, so this is a function. So function notation, equations that represent functions are often written in what's called function notation. So a function rule, the rule that we kind of go by, is an equation that represents an output value in the terms of an input value. So in other words, we're going to have to take an input and plug it into some type of equation, and then hopefully chug out the answer and get an output. So if we have the equation y equals 3x plus 2, we let y equal the function notation, or f of x, so that the equation can now be written as f of x equals 3x plus 2. So this symbol, as you know I'm saying, is read f of x, not f times x. Okay. We call the variable x that we're going to plug into, this is called the independent variable. So you can think of it as x, you can think of it as input, you can be independent variable. Okay, we also have the dependent variable, which is this f of x, which relies on the input that's being put in. So it's called a dependent variable because the value depends on the input value. So what we want to do is we want to take the examples and evaluate each function for the given value of x, and we want to write the input x and the output f of x as an ordered pair. So what we're going to do is we're going to take this 3 and we're going to substitute it in for x here. So f of 3, negative 3 times 3 plus 2. We'll see that you get negative 9 plus 2, which is equal to, yes, negative 7. So f of 3 equals negative 7. Now, if I were going to write this as a point or an ordered pair, we know it's generally xy, but we took the y and we substituted, so it's really x f of x. So our point is we input 3 and we got negative 7. Go ahead, hit pause real quick, do problem number 7, come back and check your answer. Welcome back. Number 7, you should have gotten for the coordinate x, when we inputted a negative 2, out comes the output, or the f of x, so we get negative 2, comma, negative 2. Number 8, we're going to write a function rule to model the cost of renting a truck. So we're taking the cost of renting a truck, and then we're going to evaluate the function for the given miles that we actually drive it. Well, if we think about this, the total cost that we're going to get is the daily rental. So let's just call it rental. But we plus that because we're being charged at a rate per mile. So this is the rate. So if we take the rate per mile and add that to the daily rental, that should give us the cost that we get. So if we write it in a function rule, let's use f of, and let's just put m here for miles. Okay. We're going to take it's going to cost us $19.95 to rent. Okay. But we're going to add that to the rate per mile. So we're going to be charged 50 cents per mile. Okay. So it gives us f of m equals $19.95 plus 0.5 m. If we take and we substitute in the 73 miles, we get f of 73 is equal to $19.95 plus 0.5 times the 73 miles that we ran. Excuse me, we didn't run, we drove. So f of 73 equals 1995 plus 0.5 times 73. You get a total of 5645. 5645. What we can say then is the truck will cost $56.45. Go ahead, hit pause, try number 9, check back in a few seconds or minutes. Welcome back. Given the equation, so we had f of m, or the miles that we're inputting, is equal to $39.95 for the daily rental plus 0.6 or 60 cents per mile times the miles. We inputted 48. You get $68.75 the truck will cost. Last couple problems. We want to find the domain and the range of each relation and determine whether it is a function. So we have a graph. Let's use the vertical line test. So if I draw my vertical line here, if I'm going to take this, move it through, we're still only crossing at one time, still only cross at one time, still only cross at one time, still only cross at one time. You'll notice that it only crosses one time, so this is a function. If I drag it over to number 11 real quick, you'll notice that immediately one of the first ones I draw, it crosses here and it crosses here, so this is not a function. So we can write function, not a function. Domain. If we notice, I can start here. If I go everything to the left, this arrow means that this continues forever and ever and ever and ever and ever and ever and ever and ever. So this is considered all of the negatives over this way. And if I go this way, we know that this arrow continues this way, and I can still go over this way and up to the graph, so I can go all positives. So what we can say is the domain is the set of all x such that all real numbers. Okay. I guess I could have put all like that. And the range, let's do from the bottom. So y, if we notice we go negative, we are at -1. That's the lowest it could possibly be. But if we go up, and this graph again continues, I can probably go up as high as I can possibly go and still go over to either side. So you'll know that all of the positives are okay. So we need to be greater than this -1. So we'll say that y is greater than, and considering that it is on 1, no dotted or anything, we're going to say y is greater than or equal to -1. Okay. On 11, the domain starts, if you notice the graph stop right here on the 0, go towards the 2 and stop, so we can say that the domain x is all of the set of numbers such that 0 is less than or equal to x is less than or equal to 2. And then the set of all y's, which the lowest y value is -2, the highest y value is 2. So we'll say -2 is greater than, make sure we put y here, less than or equal to 2. Congratulations. We'll see you next time. Do your best, forget the rest. Bye for now.